Hello everyone. MIDOG 2022 challenge results. I've got some interesting news for you. Now, when I'm taping this, it is around Easter in 2024, and you might wonder now that's quite some time ago. MIDOG 2022, if you are aware of it, was held on MICHI 2022. So how can that be true? How can we have new results? Let's find out in this. First of all, for those of you who are not aware about what this was about, MIDOG was a challenge held at MICHI conference, and it was about the detection of mitosis across several domains. And by domain, we mean like influencing factors such as the tumor type, and the tissue type and the scanner that was used and the lab and so on. And by mitosis, of course, we mean those tiny cells that we want to find out if they are actually dividing or not. So it's a challenging task. It's a task that is known to be challenging, and it's a task with high inter-rater variability. That is also one of the reasons why it is totally sensible to go for an automatic detection of those. Now, we had 6 domains in the training set, and we even had 10 domains in the test set. So even from different species. So we had human samples, we had canine samples, so dog samples, and we had also feline samples or cat samples in the test set. And we had different kinds of tumor characteristics in there. We had different kinds of species, as I already told you. We even had different kinds of scanners in the test set. And of course, that was quite a challenge for the participants. Another novelty in the MIDOG 2022 challenge that some of you might not be aware is that as a first time we used PHH3, so phosphohistone H3 assisted annotations as a secondary annotation to the test set. What does that mean? That means that we did our usual 2+1 annotations. So one pathologist annotated all mitosis and cells that look pretty much similar. We even had a machine learning model augmenting this to find potentially missed candidates. And then we would have, first of all, of course, those potentially missed candidates over to the first pathologist, and then we would hand everything without knowledge of the labels to a secondary pathologist, and in case of a tie, we would hand it to a third pathologist. So that was our usual and well-established way of creating those mitosis datasets. Now for this test set, and only for the test set, we also stained with this immunohistochemic stain, phosphohistone H3, which is known to specifically stain the mitosis. We also checked actually what that would mean in terms of evaluation of the challenge. So let's dive into this right now. Of course, I would love to tell you now all about the participants. There were 9 teams that participated, and of course also about the approaches that they did, but that would be just way too much for a short video on YouTube. So please go ahead. There's a link in the description below. Have a look at our just recently published medical image analysis paper. We're very proud that it's now there, and it's open access, so you should be all able to see it. Right, moving on. Of course, I could also now really look into the main findings that we had in the challenge, and of course there's like many curves and results plots and so on in the paper, but I think it's also better that you look it up there. In summary, we found that actually the challenge participants had a pretty decent score. So the task was accomplished in a way similar to human performance levels. Well, and secondary, and this is actually one of the things that I was most curious about, we had the new finding that with all of the 3 major new domain compartments, such as we had a new species and we had a new tumor morphology, which was spindle cell morphology, and we had a new scanner that was also never seen in the training set. And for all of those, actually, we found that, well, if we consider those individual ingredients to a domain statistically, then we find partially small but certainly significant differences within the results. So that was quite interesting. So even though we had quite okayish results, we still had this domain dependency across our teams in the results. Yeah, and what else? Well, I already kind of teased you a little bit here. So the use of the PHH3 in the annotation as a secondary ground truth in our data set yielded also very interesting findings. And we could just now argue that, well, this actually, I mean, this staining or using of actually the HNE and similarly the PHH3, and I should highlight here that we did actually a destaining and a restaining procedure to really have the same exact kind of tissue reflected in those two images, and we registered then both of them to overlay them for the pathologist for the annotation. And what we found here is that we have actually quite a drop in recall of all the approaches. And that sounds at first pretty logical, because, you know, like the with the help of this specific stain, the pathologist might have just been much better in spotting all of the mitosis. However, a post-hoc analysis found out that actually many of those cases were really indistinguishable in the H&E alone. So in summary, that means that while the PHH3 is actually more accurate in terms of reflecting the biological ground truth behind, it's not necessarily accurate for the H&E. So using the PHH3 labels for the H&E might come with some serious drawbacks. Yeah, so that was already it. I can already reveal that we might be looking for a successor of MIDOG 2022, but all of this of course, I will reveal as the time is ripe for that. Right, so I hope you liked it. If you want to find out more about it, please, just get in touch with us, and see you next time.